Let's jump right into this explainer and unpack a reality that honestly catches so many developers completely off guard. We're talking about why launching your software's version 1 into production is absolutely not the finish line. In fact, if we really look at it, it's the true starting point. Think about it. You've spent months writing code, fixing bugs, and finally, your app is live. It's a great feeling, right? But the very second real users start depending on your software, the rules of the game change entirely. So I want you to imagine something for a second. Imagine your launch is a massive hit. Almost overnight, you have an influx of users, exponentially more data, and just a flood of new feature requests. This is the dream. But here's the catch, and it's a harsh one. Code that works absolutely perfectly in a basic production environment can, and very often will, completely collapse under the weight of unexpected growth. When your code succeeds, it immediately faces a whole new set of challenges that building those early stages just never prepares you for. Dealing with this requires a fundamental shift in how you think. When you're just starting out, you're naturally in a beginner mindset. You're constantly asking, how do I write this function? How do I actually make this feature work? You're 100% focused on correctness. But as your software grows, you have to adopt a production mindset. The core question shifts to, how does this system behave under failure? You're no longer just writing code in a vacuum. You're preparing for unexpected failures, crazy traffic spikes, and the long-term survival of the application. Let's move into part 1, symptoms of outgrown software, or when the architecture cracks. Imagine trying to route an entire major city's traffic through a single dirt road intersection. Naturally, the architecture cracks. You're going to start seeing some very specific red flags: frustratingly slow response times, databases that completely lock up, and cloud bills that literally skyrocket as you desperately throw more servers at the problem. You'll experience frequent downtime, deployments become an absolute nightmare, and the code complexity just balloons out of control. Because at scale, you aren't just squashing simple bugs anymore, you're fighting massive performance hurdles and team coordination issues. The problems fundamentally change. Which brings us to part 2, designing for massive scale, going from dirt paths to highways. If we zoom out and picture this on a whiteboard for a moment, fixing these symptoms requires moving to a distributed system. Basically, we're ripping up that one-lane dirt road and building a massive multi-lane highway with dedicated off-ramps. Instead of relying on one giant monolithic process, you split the architecture into multiple moving parts. You've got web API servers handling the main traffic, background workers taking care of the heavy lifting off the main road, and message queues organizing the whole flow. You are intentionally separating concerns so that one localized traffic jam doesn't shut down the entire city. Notice the stark contrast here between the two. A linear process is a single, predictable blocking path, meaning if one thing takes a long time, the whole shebang waits. But by separating concerns into a distributed system, your architecture becomes non-blocking and fault-tolerant. Instead of just buying one massive, ridiculously expensive server, which is vertical scaling, you can scale horizontally, simply adding smaller servers side by side to distribute the load effortlessly. Now, unlocking that horizontal scale brings us to concurrency. Running operations simultaneously rather than blocking the system, well, it isn't optional at enterprise scale. It is an absolute necessity for I/O-heavy workloads. But fair warning, it introduces a rigorous new level of engineering discipline. Because things are happening at the exact same time, you now have to handle race conditions, shared state issues, and these incredibly subtle data integrity bugs that literally don't exist in single-threaded code. Alongside concurrency, you absolutely have to reduce your compute load. Enter caching. Instead of punishing your database every single time a user requests the exact same piece of data, you serve it from a hyperfast memory layer, like Redis. It's basically the ultimate performance multiplier. It kills latency and stops those rising infrastructure costs from bleeding you dry. At the end of the day, scaling is very often just about engineering elegant ways to bypass unnecessary work. And look, this isn't just theory. We can trace this exact evolution across the absolute giants of the tech world. Think Netflix, Amazon, WhatsApp, Uber, YouTube. None of them started with their current architectures. No way. On day 1, they launched basic monolithic applications. By month 6, as traffic surged, they implemented caching and load balancing. By year 1, they were actively breaking those monoliths into microservices. And by year 3, they were forced to design entirely new enterprise global scale architectures. They had to continuously redesign their systems this exact way as their user base exploded. Let's transition to part 3, automating quality and reliability, because growing software means scaling the team too. See, growing software isn't just about managing servers. It's about managing the human beings writing the code. This is exactly why a rock-solid CI/CD pipeline is survival. Manual deployment, perfectly fine for a solo dev. But when 20 engineers are pushing code simultaneously, it is a disaster waiting to happen. You absolutely must automate your testing, your linting, your container builds, and your deployments. Every single step has to be automated so that quality actually scales right alongside the sheer volume of code your team is pumping out. And to support all that automation, your team's infrastructure has to mature. We're talking meticulously maintained documentation, rigorous code reviews, strict coding standards, and a truly ruthless DevOps culture. Without these established workflows in place, your developers will constantly step on each other's toes, overwrite critical changes, and severely jeopardize the high availability you need for enterprise resilience. Because, at a large scale, problems hide. They really do. In a small app, you see the error stack trace immediately. But in a massive architecture running thousands of concurrent processes, a critical failure can be completely buried under mountains of data. Observability is quite literally the difference between panic and control. Centralized logging, detailed metrics tracking your latency, and automated health checks, these aren't just nice-to-haves, they are the bedrock of scalable, measurable systems.
Now for Part 4, AI in Modern Scaling, the Force Multiplier.
Today, we're seeing a massive, massive shift in this landscape. Integrating AI actually moves the burden of scaling away from human guesswork and onto intelligent, adaptive systems. It's a real game changer. We're seeing AI provide deep, intelligent monitoring, predictive scaling that actually spins up new servers before the traffic spike even hits, coding assistants that enforce your architecture standards on the fly, and hyper-accurate anomaly detection acting as an automated 24/7 defense line. To put that into perspective, the real-world impact here is staggering. Just look at the disparity in issue resolution time. With manual monitoring, teams are spending about 85% of their time just hunting down bugs and digging through endless logs. AI anomaly detection drops that to 15%. It automatically flags the root cause and verifies system health, which frees up your engineers to actually build the product instead of just constantly putting out fires. Finally, let's look at Part 5, the engineering mindset shift, systems over files. So as you start building out these enterprise-grade systems, keep a few highly actionable rules in mind. First off, don't over-engineer version 1. You really don't need a massive microservice architecture for your first 10 users, but you should absolutely design with clean boundaries so future growth is seamless. Always measure before you optimize. Let your observability tools actually point out the real bottlenecks. Prioritize maintainability, and always remember, scaling isn't a destination, it's a continuous, ongoing journey of measuring and adapting. There's a saying I absolutely love that perfectly captures this evolution. Moving from script to production makes you a professional developer. Moving from production to scalable systems makes you a software engineer. One is purely about correctness. The other is about longevity, resiliency, redundancy, and architecting a system that fundamentally thrives under pressure. This right here is the ultimate transformation. You stop writing code in isolation, and you start designing systems. If your code can survive massive traffic spikes, exponential team expansion, and completely unexpected server failures, well, you're no longer just building software at that point. You are building durable, scalable infrastructure. Thank you so much for joining me on this explainer. I want to leave you with this one thought. The next time you sit down to write a feature, ask yourself, are you just writing code for today, or are you truly architecting for tomorrow?